My name is Adam Moore, and I'm the Programming Chair for the Fertilizer Show Conference 2026. This is the second in our series of interviews with speakers who will be joining us at the show in Tampa. Today, I'm delighted to be joined by John Nixon, Global Group Vice President for Process Industries with Siemens Industries Software. John is going to be speaking about digitalization for a sustainable fertilizer production. John, great to have you with us today. Thank you very much. Let's start at the beginning. What is digitalization?
Well, Adam, thanks for having me. And that's always the question, right? What do we mean by digitalization? Now, from me, I spent more than 2 decades out in the field, right? And so for me, digitalization is something that when we define it, it has to have real world applicability, both on the factory floor and the field. So for me, digitalization is that journey from concept all the way to the factory floor, or from concept all the way to the field. So for example, if I'm in a chemical plant and I'm looking at a pump, for example, my question is going to be, who did we secure that from? Meaning, who designed that and who fabricated it? Who received it, transported it? Who then received it at the facility, inspected it, installed it, commissioned it? It's been operated. Who has been maintaining it? And where are those maintenance records? So I want to know from birth all the way to current day, if I'm looking at any asset or any product, all the data associated with that. And we were talking earlier. One of the questions you've asked me before is, John, data's always been with us, right? We've had incredible volumes of it, for decades, right? And so, yes, we've had literally boxes on pallets of folders of files and information. We've had endless thumb drives of PDF documents and so forth. And so, you get into these situations where when you're looking at an asset, right? So you consider the fact that you've got an incredible wealth of data around it. And if you have any issues with it, forensically speaking, it's going to take you quite some time to kind of sort through boxes of files or thumb drives of PDFs or, network folders that are endless, that are containing, again, discrete files. It takes a lot of time to go through that. When you have issues like in chemical plants, production facilities, like for potato chips, food and bev, or beer, or anything like that, when you look at the process industries I'm in, every day you're down, you're losing millions, right? You're losing an incredible amount of wealth as a company. So your ability to forensically move through data and understand what your issues are is paramount. So digitalization, again, if you understand the full life cycle of any asset or any product, and you have the ability to visually navigate that rapidly, right? And be able to assess what my issue here is, that provides you real value. So digitalization is not digitalization just for its own sake. It has to provide value to you as a customer in design, in manufacturing, and in operations, right? As you move through that life cycle.
I mean, it sounds to me that digitalization is a process in itself, and it's an ever-evolving process, right? I mean, companies around the world have been digitalizing from letters to emails. Then in a very different life, I worked on CRM implementations, SAP, Oracle, the first time supply chain management software started coming in. And, some of the costs of some of these projects were astronomical. And in some instances, they shut down some operations for a long period of time. So how does Siemens come into this space that's already got so much digitalization around it, and how can you really sort of meet those needs of today, where we're in an ever-evolving, ever-quickening data world? AI's coming in, there's been those boxes out the back that have suddenly now been installed, and we're getting all this new information all the time. Right. I mean, it seems like a huge job, John.
As you're saying that, I kind of smile because you're making me feel old, because I remember the ERP deployments of the 90s and everybody going, what is ERP? This is a new concept, right? Enterprise resource planning. And everybody had a different definition of what they thought ERP was and everything. So you're right. And by the way, just to further show my age, when I was in the Corps of Engineers for the Army, I remember when we had Windows for Work groups 1.1b, and I thought, oh, this is so cool to have network folders and be able to share things, across the base and from one base to the next. So just very interesting journey that we've had as a species in what you're talking about, these various surges, ERP, EAM, CRM, CMMS, all these abbreviations and acronyms for all of these new incantations of, digital solutions, if you will. But what ends up happening is you get a very federated, right, environment, right? And so to say the word siloed, right? We hear that all the time, but it truly becomes that way, right? And so you've got all this siloed information. So here's the key right now. If I want to get value, a greater return on investment of what I've already invested in, what I've already spent money on, I need to be able to go in there and be able to pull data from these various sources of truth. You often hear single source of truth. Jennifer Petrosky, who works in our team in life sciences, I once heard her say, well, really, John, what I envision, this is really an authoritative source of truth is what you're looking for. So, because everybody seems to have, they've got their accounting data, they've got and along with their cost data, we've got scheduling data, we've got asset information, like you were just saying, CRM and ERP and all these different systems. How do I move in and then be able to liberate and create a semantic layer, right? Create the meaning. So if I've got an asset, right, I've got ERP data associated with it. I've got enterprise asset maintenance data or management data associated with it. I've got CRM data associated. There's all these different sources of data that will have either a loose or tight affiliation with that asset, right? And so to your point, there's been decades of investment. What if I brought in a knowledge graph, right? Or maybe an integration strategy and was able to then create a semantic layer. And then I can start talking about providing a retrieval augmented generation capability, a RAG capability to support my artificial intelligence implementation. Because I know where you're going with this, Adam. It's like everyone's talking about AI right now, right? It's you wake up to it, you go to sleep. It's a headline you see everywhere. How do we get real value out of an AI that doesn't hallucinate, right? And so to your point, I can go back, I can look at all these investments and I can liberate more value out of it because we have such an incredible way to come in now with a knowledge graph and an active integration capability with your existing investment. So, a lot of times people are like, oh my gosh, and you pointed this out, is this going to be months and months and months to roll out? Is this like an ERP rollout again from the 90s? The answer is no, right? And the beauty is the vision that we at Siemens have set for an industrial metaverse, there's a journey there that doesn't mean I have to shut everything down right now to implement this. Yeah. You can handle it one step at a time. And again, like I said, by coming in with something like a knowledge graph and with an integration strategy, a data strategy. In fact, I often say, I heard this one time, so I'm borrowing this from what I heard from someone else at a trade show. They say, if you don't have a data strategy, you don't have an AI strategy. Couldn't agree more, right?
Yeah, so that almost seems then, too good to be true, to be honest with you. I remember some of the ERP planning systems back in the day were always going to be done in 5 years, and 15 years later, some of them still seem to be going. So is this something that your teams could come in, if I'm a producer, and you could show real-time improvements in kind of a testing capability? You could tap into some of my system and have a look at that. And, how does that really work? Because when anyone says they're going to save me time, it usually means dedicating a heck of a lot of time up front.
Right. No, this has been a challenge with our customers again and again and again. And we've actually developed a process called a digital maturity assessment, right? Our ability to come in and have a very light touch and within days and weeks, be able to provide you effectively, here's your current posture. Here are the steps we would recommend you take to build up to the end goal of the industrial metaverse that we're all trying to get to. That's a physics-enabled environment where you've got AI that's providing insights and you're powering your humans on the factory floor and in the field, right? So what is that path to get there? And I've often been asked that by customers, John, where do we start? Well, we start with that maturity assessment, which does just what I said. We get a current state from all the investments you've made over the decades, however long your company is, or if you're a small company, where you are today and what you need to build up to. So, I can say what the beauty is. Again and again, we haven't had to do major overhauls of marquee customers and spend, years and years and years where you're not getting any value. We're able to come in and provide value rapidly. In fact, there was a recent press release just came out the first week of January, while I was at a trade show, and it came from PepsiCo, and I think I've shared the link with you, Adam. And please feel free to share with anybody that's listening to this.
We'll put it in the
recording
link.
And everything. And they talk about how because of our digital twin composer, right, is what we call it, our ability to digitalize the factory floor. When you look at facilities that need your food and bev company, and so you're looking to have a new line of chips, or you want to increase your capacity to produce a certain type of beverage, and you've got hundreds of sites. The question you ask yourself is, okay, how can I actually plan the debottlenecking or the expansions, the change in configurations? How can I do that all virtually long before I, actually put a human on the ground to make physical change? And so we've done that. We now have the power, thanks to our partnership with NVIDIA, right? The compute power has now caught up with our dreams as a species as to what we can do. I mean, imagine this. You're looking at a factory floor. You've got this, maybe a factory that's 30, 40 years old, and you're looking at it and you're going, I've been told we need to look at increasing capacity by 20%. Oh my goodness, how do I do that, right? Well, now we've created a physics-informed digital twin of the facility down to the product itself that's being produced. But we can create a digital twin of the facility, your forklifts and their dance with humans on the floor, all of your rollers, all of your production machine, every asset within it, we have a digital twin. So think about that. At every scale, there's a digital twin, and it comes together as the complete digital twin of your factory. You can now make changes to it and rely upon those design changes to mimic what will really occur in the real world when you actually commit the capital and commit the work. And the beauty is, if you look at that press release that went out from PepsiCo just recently, they saw a 10 to 15% reduction in capital expenditures because of this physics-informed digital environment. Now, I mentioned NVIDIA before. The challenge has been, our kids were raised on Xbox, PS4s, right? I myself played Halo a few times on Xbox, right? More than once. And you get used to this kind of massive model capability that exists in the digital world. Now, of course, they have gaming physics. That's not real world physics. But what if, and I think the expectation is that what if I could mimic that, though, in the real world? And we can do that now, right? You've got NVIDIA and you've got Siemens working very closely together to now provide, an environment that really runs on the laws of thermodynamics and physics, which we experience in real life every day. And we can now simulate that with high fidelity, thanks to the compute power that we now see is available. And, more thanks to Moore's Law, we know that compute power is going to go up. It's going to become ever more affordable as we advance forward as a species. So I'm excited about the future that my granddaughter, for example, is going to experience as she's growing up. It's just tremendous.
No, it's great to hear that enthusiasm, and thanks very much for giving us permission to share that article, because I saw you present at CES, and when you look at those types of numbers, they just seem too good to be true. And I imagine, in your world, process industries, I mean, that's a very, very big world. When you're looking at digitalization and the types of different process industries there's a plethora of them, shall we say. So, incredible to hear the work with, big manufacturers like PepsiCo. Why is the fertilizer industry of particular interest to you?
If not to be overly dramatic, but without fertilizer, without agriculture, our species ceases to exist. And so, I want to, since I became a grandfather a couple of years ago, and I could say a father, with my sons and everything. But when I look at my granddaughter, I realize every day that we need to leave this world in a better place than we received it. And so when you look at the fact that the population on the planet is ever growing, right? Our demands upon it from an energy perspective, because, data centers and AI and everything are demanding more energy and so forth. There's this this ever-growing complexity, ever-growing demand on this planet, and agriculture, and specifically fertilizer, right, which is the reason why we can support the billions of people on this planet. It's one of those key capabilities as a species we need to be aware of, and we need to be advancing constantly. And so, when I came here to Siemens, I came out of the energy space. And so, one of the areas that I always focused on was how to drive digitalization into energy to support energy wealth for all, right? And so now I look at fertilizer and I think, well, guess what? We've got all this computational power now. Hello, NVIDIA. We've got all this digitalization. Hello, Siemens. We've got now, we're at the precipice of boundless energy. Hello, Commonwealth Fusion Systems, one of our customers that's pioneering that. If we bring all of that in support of the fertilizer industry, imagine what that does from a perspective of taking care of future generations long after you and I are gone, and what that means to them. So my philosophy is one of health, wealth, and shelf, right? So I look at the pharmaceutical industry and what we can do to improve health there through our digital support. I look at wealth. Energy wealth is the GDP of any nation. So providing, energy, boundless energy, because of the digital solutions that underpin that, is wealth. And then I look at shelf. What are we putting on the pantry shelf of every home around the world, right? And if you trace it all the way back, you find yourself coming back to fertilizer. And so I'm making it my personal mission right now to go into the fertilizer industry with Adam, and for us to do everything we can to provide the solutions needed to take what probably is seen as a bit of an industry that hasn't been necessarily disrupted a lot, but I think there is a lot of opportunity for exciting developments in this space, right?
Oh, it's so much happening already. I mean, when I was doing some research calls a few months ago, I remember speaking with someone and they were saying, some of the concerns with the fertilizer industry is because of the ammonia use in energy production. And that could impact the amount of ammonia that's left for food, as you're saying. And this industry is evolving at a huge rate. There needs to be increasing in that production. It's a very historical ways, and an incredibly fast evolving industry in many ways, with new players coming on, other players increasing capacity. Obviously, the geopolitics of this industry, is similar in many ways to oil and gas. And so I think, our theme for this year is efficiency through production, and digitalization seems to tick all those boxes for sure.
Well, it's funny. You just now mentioned that power is a bottleneck, it sounds like, around ammonia production and so forth. Funny how power is a bottleneck to data centers. Power again and again is becoming this bottleneck, and of course the grid associated with it to support all of this power supply. So it's interesting to hear that. Of course, we could have a long conversation. In fact, we could even bring in Commonwealth Fusion, X Energy, and other customers of ours that are all. I got to tell you, I'm so excited. The next year, the next 2 years, the next 3 years, we're just like you and I. Well, me, you're a young man. Just like I have, just like I've seen the growth of the personal computer, right, and the smartphone, right, in my lifetime. These changes that have occurred that have, come along and fundamentally shifted how we operate as a species. I'm here to tell you, you're about to see some fundamental shifts in power generation that are going to change, right, our ability to meet the needs for, like, for example, ammonia production, urea production, nitric acid, whatever the products are that we need in fertilizer. And, then there's the laboratory. What are some of the deep studies we need to do around soil and soil mechanics and interaction with fertilizer? And we don't have enough time to kind of go through what are all. If I was a soil scientist, and I wish I wasn't in this conversation, but if I talked to a soil scientist and I looked at a chemical engineer, I would imagine the innovations that could come out of the laboratory, that if they just had enough digital capability, enough compute power, they could change the world. Well, guess what? That's what we're bringing. So you said earlier, so I'm going to correct you on this. No, you said earlier, some of these numbers seem too good to be true. They were aspirational 20 years ago, right? But now, thanks to our partnering with NVIDIA, thanks to the development we've done at Siemens Digital Industry Software, we're now recognizing this again and again with customers. And so, and I'm not to plug our website or whatever, but if you go look at our blogs and you look at a lot of our customer stories, the kind of efficiencies we're achieving in automotive and in aerospace, with industrial machinery, heavy equipment, like in construction and in agriculture. In fact, for every car, aircraft, or boat on the water, for every one of those that you see out in the world, they were either designed in part or wholly with our software. And so it's incredible to see what we do in what you might call the discrete manufacturing world, discrete things like cars and planes. And then you look at what, the world of process. How do we bring that manufacturing mindset into this space? In fact, that reminds me, back in 2015, Brian Ferguson, who was the CEO of Synovus Energy at the time, was interviewed, and there was a big fall off for the price of oil in the latter part of 2014, early 2015. And everybody's pulling their hair out because now all these capital projects are ongoing in oil and gas. Now it's looking like, we're losing money hand over fist on these capital projects. And Brian Ferguson said, that's it, we're done. We must bring a manufacturing mindset to capital projects, capital deployment, to paraphrase him. So that always resonated with me. And so that's always been my mindset, is how do we bring the lessons of manufacturing that we have learned over many years, apply that to this space so that we actually can achieve these numbers, because they have been achieved in the discrete world. Let's bring it into process. We've done that, right? And again, while it was aspirational years ago, it's attainable now when you look at Siemens and NVIDIA and how we work together.
So is this just about retroactive looking at my processes? If I'm going to start a brand new company, I'm starting Adams Fertilizer, my brand new facility, shall I come to you then as well?
Okay, so we talked about brownfield. Well, on greenfield, right? This is my world that I've come out of. The beauty is now we can bring a digital twin into the field, right? We can start looking at what I call capital asset lifecycle management, right? That journey from design to this new facility. So I tend to focus on brownfield initially, because brownfield is 80 to 90% of what people are having to deal with. I've got existing facilities and I've got to do more with them, right? But when it comes to greenfield, absolutely being able to design, again, the full digital twin that's in let's say a coordinate specific geospatial environment that accounts for relief and elevation, soil mechanics, your sheet piles and your foundations and everything that goes on subsurface, all of that design, that can now all be accounted for and physically represented and visually navigated with that physics enablement. So it's exciting to see the level of complexity we can bring to life. In fact, there's many cases where we're working with battery manufacturers, right? So battery manufacturing, that's brand new. That is nothing but greenfield in many cases. And so we have a whole litany of discussions and stories we could share about battery manufacturers, their greenfield needs for production, and how they designed and simulated and then manufactured and operate, with our digital backbone. So yeah, that exists today.
I mean, part of your talk is talking about how digitalization drives sustainable fertilizer production by connecting recipe design to plant operations. That particularly sort of surprised me, because when you were talking about PepsiCo, obviously Pepsi's recipe, yes, I assume, is locked in a safe somewhere, and so recipe design never really comes into it. But looking at fertilizer and different new coatings and the evolution of different deployment strategies and the chemical compositions of fertilizers, so you can access real-time information then as well.
Well, when you mention recipe management, when it's one thing to start off with formulation in the lab, it's another thing to move at scale to now produce this new product. And if you're going to produce that new product in different geographies, Well, there's different palettes, right? Different cultural palettes. So therefore
Course.
different ingredients, things like that. You're going to have different machines from different types of manufacturers that may perform similar capabilities, but they're still going to be different. So the ability to have an integrated life cycle management environment, right, that connects all of your factories, right, and then allows you to account for variations in machinery, variations in ingredients, variations in, let's say, cultural palette. That kind of capability is now, we have a digital twin of that as well. And so, your labeling requirements are going to be different. Your ingredient, what you're actually responsible to put on the package is going to vary, country by country, region by region, and so forth. And so that becomes quite complex to pull all that together: labeling, packaging, formulation, doing it at scale across, the entire globe. And we have that capability now. That's what's so powerful. We're doing that now for our customers and accounting for all that variability in the digital twin. And the beauty is when you look at, like, say, recipe management, and you say, okay, I'm going to have to do a shutdown at this facility. And so where can I increase capacity elsewhere? And do I have all the right ingredients? Do I have the right machinery? And if it's different machinery, can I change the, let's say, the mix, the proportions and so forth to account for the different capabilities of that machinery, but still get the same end result? Absolutely. And we do that now. That's what's so incredible.
I mean, there's just going to be so many real world case scenarios that you can speak to people about. Who should be coming to see you present at the Fertilizer Show?
Great question. Everybody. So you look at, of course, we're all victims of our own experience. So what I tend to speak to is I want to speak to program managers, project managers, engineers. I want to talk to field engineers. I want to talk to people who are on the factory floor. But, you need the decision makers there. I mean, you need the C-suite individuals, your VPs of engineering and so forth, present to have a conversation, but I can articulate the value of what I'm asking them to look at in the hands of the people in the field that make the difference, right? So I can talk to your enterprise staff about the needs of your frontline troops. And so I get real excited about that. So when I say everybody, it's a little tongue in cheek, but it's your decision makers and your implementers. I want to speak to them about what we can do to support them.
Well, it just seems like an implementation like you're offering affects every stage of the business. So everyone needs to be informed at some point.
If you work in the lab, we need to talk about electronic laboratory notebooks, or how we're going to do, transfer from the lab to at scale. We need to talk to engineers about what that looks like, because it's one thing to have a beaker full of new product. It's a whole different animal to activate an entire supply chain to be able to produce that at scale for millions of people. And so every stage of the business, like you said, from, inception all the way to full at-scale production, we need to address what that looks like. And, I'm proud to say in the 10 years that I've been here at Siemens, the kind of investments we've made have been just like that, right? How do I provide better design tools? And we've made deep investments. How do I drive better simulation, computational fluid dynamics, system-wide simulation? What does that look like? We made huge investments. We brought in a company called CD Adapco. Shout out to all of my brothers and sisters when they came in. Just a huge array of solutions there. Now we've got Altair and Dotmatics. It's tremendous, the investments we've made over the 10 years I've been here. And how, to your point, you tell me the stage and the scale of your challenge, we've got solutions. And our solutions are all wired together. So the beauty is we provide a data backbone to all of this. So again, to go all the way back to the beginning of our conversation, when you look at the forensic needs you have around any asset, you need a life cycle that has data that is tracked. You've got a schema. You're able to develop ontologies, relationships from one data point to another, be able to provide context, right? This pump is here in this chemical plant, but which system is it a part of? What part of the plant is it in? What product is it, helping to produce? There's all this context with it, right? And then there's all the long-term maintenance and optimization of operations. So to your point, every stage digitalization, to be a little selfish, yes, Siemens, my employer, we have solutions at every stage.
Phenomenal. Well, John, I mean, I'm not surprised. My clock's just told me we're running over time, as we guessed we might do. I think we might have to do a follow-up, to be honest with this. I mean, it covers so many bases. It's fantastic. So I'm going to host that article that you mentioned about the work with PepsiCo with this article and link back to Siemens Digital Industry Software. You're going to be exhibiting with us at the show. So anyone, any questions on digitalization, come down, meet John, see him present, and I'm sure you'll be well informed, as you can see from this interview. So thanks very much for your time today, John. Really appreciate that and look forward to seeing you at the show.
Now, Adam, I could not be more excited. Let's get after it. Let's go help the fertilizer industry.
We're in it together. Cheers, John. All the best.
Cheers.